Good afternoon, everyone. Welcome to our webinar, Advancements in and Best Practices in BIM, organized in collaboration with Engineers Island, the Young Engineers Society, and Ethos Engineering. Today, we'll be diving into building information modeling, discussing tips and strategies for effectively integrating BIM into your workflows. Our guest speaker is Rubens Lopes, a digital project manager with over 20 years experience in construction. Rubens is focused on continued learning and creating BIM automation to boost efficiency and reduce costs. He has extensive experience in BIM, automation and coordination, model analysis, and clash detection. Rubens also holds a master's degree in applied BIM and management, along with numerous certifications in Revit, Dynamo, and Navisworks. In this session, Rubens will guide us through the latest advancements and best practices in BIM, as well as real-world applications and case studies demonstrating BIM's value in construction projects. We'll wrap up with a 10 to 15 minutes Q&A session, so please feel free to type any questions you have into the chat during the presentation. I'll now hand over to Rubens.
Hello, hi everyone, and welcome. Thank you for your time. Yes, so we're going to have a look at some advancements, best practice in BIM. So they're based on experience. Yeah, so let's not waste time. Yeah, just going to talk a bit about Ethos. That's the company I'm working now. So working since 2005, delivering high performance MEP, solution sustainability, digital design management. That's the sector I work, so design management. Just a bit about me. Don't worry, I won't read all that. But I started in 2001 as a civil engineer trainee, then technician, then site engineer. I moved to Ireland in 2018, then started again as a CAD technician, then structural Revit technician, BIM coordinator. Now I'm working with Ethos as digital project manager. BIM. Okay. So I finished my master's degree, and my paper was about analyzing as-built model using Dynamo and Point Cloud. Then I did a couple of presentations, and yeah, and next week I have another presentation that's there, next event, and the other week another presentation as well. One is about AI, AR, VR, and laser scanning. Another one is how sharing experience, how I'm using AI in engineering. Okay, so if you want to know more, you can have some links on my LinkedIn. Okay, so what we're gonna do, how's the structure of this presentation? So I'm gonna talk about some BIM advancements. So things I think they are important for information workflow, tools, techniques that I'm applying in projects, and talk about the results on real world projects, and share some case studies. There is a thing here, of course, like I can't share any client information, so I cannot show like the design from the client because that's sensitive information. But I can share my experience. I can share real things that happen. So, and my proposal here is let's build a data center together. So we go through the process from the concept design to the handover. Okay, so and then I'm gonna adding those BIM advancements and workflows and techniques, tools that I learn, and telling a bit about some examples. Okay, so let's do it together. So let's say to build our data center is we have an empty site and the client wants like a state-of-art data center, and it's always tight deadlines, as everybody knows. So we don't have much time to waste. And our strategy is to get implemented BIM workflow using ISO 19650, best practice, common data environment, and then bring the team together to work together. So, and we're going to use some information management foundation. So we information management principles that I'm going to share in a couple of slides. So what are common issues, information management challenges? So we have data inconsistency. So it's like sometimes it's the version, you don't know if what's the latest, you know if it's in the correct file format, and sometimes communication. So the team doesn't know where to find information, or they are linking to the wrong information, or they're using wrong channels. Sorry. Or is, let's say they got the correct version, communication okay, but the quality of information is really poor. It's like it's missing what you need, or it's just wrong. You know? So here, like that's not my idea. Those are general principles, information principles. So the main one I keep repeating and is trying to implement is single source of truth. Okay, I'm going to give an example about that. But if we implement structured data management, we're using this principle, single source of truth, then we're going to eliminate this confusion of conflict versions. Oh, I don't know what's the latest. I don't know where to find, because it's supposed to be just one. So we're supposed to know where the information is, and it's always there. And for communications, real-time collaboration, we need to use tool CDE that provide us with all the features that we need to have real-time collaboration. I know there's I'm going to talk a bit more in detail about CDE, but there are many options in the market. Let's say, oh, BJ60, ACC, SharePoint, Procore. So we need to get those. I think we need to get one that gives us the ability to collaborate in real time. And BIM standards and QA/QC process. I'm writing BIM here just as a short, but for me, BIM is the building information management. So we need to have information principles, information management standards clear for everyone and well structured. Then, so once everybody knows what we're expecting, then we can implement a QA/QC process and then get the correct data, good quality data. So let's, in our data center, okay, that we are building here in our project, we need to have a file naming convention. Yeah. So that's, if you search internet, you're going to find this file name there. So it's project, organization, location, and then like people say, if you search like ISO naming convention, that's what you're going to find. Okay, and here example, some files that they're using this naming convention. Can you say which one is the latest? So it's the same file, just different versions. You see there, so you have suitability as 3, and then version 1, version 2, and then suitability as 4, version 1. And let's say if you were very well versed in the project naming convention, you can spot and say, okay, no, that's the S401. But let's say someone is not that aware, they might think, no, it's the 03, because it's the version 3. So it's not clear. So what we are using, it's not that. We don't add the suitability code. We don't add revision in the file name. We go up to the number, and we only have one file. That's it. Oh, but what happens when you have different versions? We overwrite them. So you see there, version 4. So you have these 4 versions in the same place. Oh, but I want to recall, I want to see the version 1. So if you click there in the version 2, you see the previous version, and you can go back there. That's it. So there is only one file in one place. That's it. It's simple. Of course, like there are some people, oh, but I want to know the package that I issue for the client, and that's another thing. Like you can still use this, but it's simple. Like no one's gonna ask you what is the latest, which is the latest. So another advantage is it's always the same link. Once you give the link, that's it. You don't need to be updating. Person won't say, oh, I lost the link. Nope. If you create RFIs, issues, and then you link to that file, they're always pointing to the same file, so you don't have broken information. In the previous version, the the one with revision and so on, if you add a comment in the version 1, let's say S301, and then the designer, they upload, okay, now it's version 2. Your comment is not in this S302. Your comment is S301. So how do you know if they fix what you asked? That's different if you have the same file overwritten, because the comment is still there in the same place. They're just the background, that's the design, that changed. So now you can see exactly where things are. It's easy to compare versions using this version too. You just click there, there is a button, compare versions, overlay them. One is red, it's blue. So you have the difference. And I have to say, give me a lot of peace. People not asking what's the latest, where is the latest. Last work. Okay, I could not resist. That's a very old thing. So there can be only one. So if we have only one file, that's it. So it's easier. Okay, and how about the folder structure? That's the ISO scheme for the folder structure. So you have a work in progress, shared, published, archive. Yeah. So let's say in our project, the previous BIM manager in our data center project, they implemented the work in progress, shared, and published. But then, for instance, the architecture, every time they publish a new version, they create a new folder, and then they put the date. And so you guess, like, that's not ideal, because again, you're breaking the link. You don't have one source of truth. That's the first principle. So no, it's simple. So let's organize the information not per date, but per use status. So if it's in work in progress, it's in work in progress. You give access to only who can have access to that. Once it's shared, so it's shared with the team, and you give access to the team. And once it's published, then you change the status and go to publish. Oh, but then we have three files. Yeah, but at each status, you only have one. Okay, so it's one. So it's easier and less folders, less work. Okay, so now we have our naming convention. We have our folder structure, trying to keep things simple, using principles. But we need a tool. We need a CDE that allows us to use all those features. For example, if you are using Windows Explorer in your computer, you can't overwrite files and have the version there. That's why I think in the past they created that system where you have to rename a file and put 01, 02, 03. But that's not the case anymore. We have tools, they support version history, so you don't need to rename that. So you don't need to use this thing here. You don't need, that's in the past. Okay? So you, version control, your CD needs to have version control. You need to have also a CD that can allow you to link and view files without downloading them. And so, for example, again, if you using, yeah, that's my personal opinion. Okay, it's nothing to do. For example, oh, Procore, for example, and then you got you want to open a module there, so you can't open the module directly. You can't link one to another. It's the same with SharePoint. You can have modules there, but you can't open them. You can't link them, so you can't collaborate real time. SharePoint, you have version control, but it's not as clear. You have access control. Yeah, you can give access to for per folder. So I think those are the features that I think they're very important you have in your CDE. So you can have one source of truth and you can have real-time collaboration. Those principles we talked. And granular control. So you need, sometimes you just like a view only, like a view and download or view and publish comments. Like you don't want to people have access that they don't need. So you want to only give them the correct information and the access they need. It's just the information needed. Okay, now BIM standards and QA, QC process. So there are ISO standards, there are a lot of guidelines, and then documents, okay, you can do OIR, AIR, PIR, BEP, TIDP. Each one like can come from the organization, the client, or then your BIM execution plan, and then your task information delivery plan. So you need to have a plan, standards that were said before, like we need to have a plan, a strategy. So let's say in our data center project, we have this. And then once we know what we're expecting, we have a standard, we set what we want, then we can have a QA and QC process. And then we're going to check, oh, what are the information requirements? Then we look at there in our BIM standards we create. What's the level of information we need? It's there in our documentation. What's the level of detail? It's there in our documentation. So there is a very important difference about level of information and level of detail. And we're going to talk about that in the following slides. The model parameters. Do you have all the information in the model? Is our model the center of the information? So we have everything we need there. And of course, spatial coordination. That I think that's what most of the BIM is more famous for, is kind of clash detection and so on. Okay, so we have standards, we have a process. So let's implement that. So in our project, we are implementing this. We are using standards, we have templates, we have a workflow, we checked everything. There we go. We get what we expected. Our sandwich that the client wants. So exactly what they order, that's what we deliver. That's good. But let's say something happened and then things are not okay, or either not using standards, you're not using templates, not using the workflow, not checking. So you have the templates and workflow, but you're not really checking them. Then we won't get what we won't deliver what is expected. We won't deliver what the client asked us to do. Okay, so, and in terms of model, not sandwich, it means that it might not be coordinated, missing information. For example, you need the structural team need the weight of the equipment so they can calculate the structure, of course. And so they receive the wrong size, the wrong weight equipment. So the structure is not fit for that equipment, or then the size. When you buy the equipment and you go on site, you can't fit it there because it's just not the correct information, is not the correct size. Okay, so that's all our principles. But now we are using Riba to differentiate stages. So we are in the concept design. So we have like a very high level information about, oh, what is this building? Where is that? How many floors? Size? Many projects, they don't model the concept design. I think they should, because then we can bring other stakeholders to give their opinion and say, oh, they can visualize. While these things are just on paper, 2D, it's hard for whoever is not an engineer or whoever is not an architect to understand what's happening. So we need to visualize what's happening and then share, so we avoid miscommunication, and then we have a clear solution. There are many tools. I just pick one here. That's Forma. So let's say, oh, the architect presents us 3 options for our data center. Okay, so we can have a building, a central building, and then smaller buildings, or we can have like a 5 or 10. So that's much easier for, say, bring the client on board, investors on board. So, and then they say, no, I don't want the option 1. I want option 2. It's more clear for me. And then there you go. Like, you don't need to be discussing those major concepts anymore, so you can keep progressing, going back. Okay, so once we have our stage 2 approved, we go to spatial coordination. And in the spatial coordination, we start adding more complexity. Now they're not just boxes, so we need some shape there, but you don't want to have like a high level of detail there, because it's not defined yet. You don't want to make your model heavy, but you need to have some kind of accurate dimensions. So you can perform your clash detection, and then you keep progressing the information as you need. So the level of information need. Like, too much information is not good, too little is not, it's not good as well. So we want what we need. Okay. And then we can perform our coordination. So we did, in this project here, we did our clash detection, we checked the level of information need, it's good, and then we did our coordination. So we checked the level of detail. So the level of information need and the level of detail. So sometimes there is a misconception of saying like, oh, the higher the LOD, the best. No, the LOD is level of detail. So why do you need in stage 3, when you're just doing a spatial coordination? Why do you need to see a screw? Why you need to see like your, small things? No, you're doing big dimension spatial coordination. So you don't need that. Okay, so again, that's in our BEP, but it's not just about the geometry, it's about the information as well. So in the stage 3, for example, I need to know dimensions. I need to know what's the weight, what's the materials. And so the other teams can work with that. So why do I need to know materials? Because the sustainability team might do a calculation and carbon analysis, and they say, oh, well, and then they can start suggesting, no, we can reduce our carbon footprint if we change this material. But that's information, it's not detail, it's just information. It's the same for equipment size and how heavy is this equipment. So the structural team needs that as well, so they do the design. And then you keep progressing and things are more defined. So we go slow, detail, information, it's easier. But you also have our clash avoidance strategy. For example, we don't want the sprinkler team modeling before everyone. So we need to have some order, because there are some priorities. So that's an example from Plenary website. It's a very well structured. So you start the architecture, then the structural, and then service, civil, then gravity systems. Of course, like a gravity system, you can't bend up, let's say. You need to follow gravity. So they have priorities. So if we model first, we reduce clashes, we reduce rework. And in this example, the right-hand side, it's the same uh, from plenary. So let's say you have a clash there. You could solve in those two ways. One is very costly, another one is cheaper. If you follow this order, the design priority, the way to solve this clash is going to be more efficient and it's natural. Like you don't have, let's say, all the firework teams and then they model all those curves and then the QS at the end of the line say, oh, why do you have so many? So go back and redo your work. So if we follow order, it's going to be easier and reduce costs. And also we need some rules. What is allowed? What I'm going to consider a clash in stage 2? What I will consider a clash in stage 4? Okay. Of course, if you are in stage 2, as 3, as I said, so you don't need to go too much in detail. But of course, there are some red flags. So, but that has to be clear for everyone. Let's say I will have a pipes crossing a wall perpendicular. So I know that in stage 4, I can create an open there, and then I'm going to solve this clash. So I'm not considering it a clash at the moment. But that's clear, like EP, so everybody knows. If you're crossing a beam, let's say it's a precast beam, so it's a kind of yellow alert, or might be a red alert, depends on the structural team advice. But that has to be clear. Okay. Okay, so we did our spatial coordination. We just issues. Now we go to stage 4. And then we need details because after this stage is construction. So now we're going to increase the level of detail. We're going to increase the level of information. So we need specifications. We need like what's the equipment model. Like if you're using the generator, okay, I want to know which one is that, and let's see if it's available. Who is the vendor? And this information ideally would be in the model. So when we pass to the construction, that's the next stage. It's not there. It won't have too many surprises. So your coordination is better now. So we can do a smooth transition to stage 5 and construction. And then we go to construction. Okay. And that's what many times the coordination between the BIM model and the construction side kind of misaligned. So what I'm saying here, so we need real-time monitoring. So that's not something common. I've seen many construction sites, but it's completely possible. And I work in projects where they have that real-time monitoring. So what's that? So in this image, you can see it's a tablet and a GPS connected to that. And then they have the model information. So you can overlay reality with the design. And then you already check in there if it's the correct place. So you don't need to build wrong or like have a mistake or just look at paper and then find out later. We can have real-time checking. So we are bringing what we dream, what we design, then bring to the site. So in our project, let's say we are using that. We have issue detection. So whenever we're using this technology, we are catching issues right away. And so we are building our digital twin because whenever we build, of course, there are some deviations, and then we update the as-built model. And that the as-built model is not something that we only use at the end. We are using during the process. I'm going to show a bit more about that. The next one. So why do we need to coordinate the as-built model? What I'm saying about coordinating the as-built model. So when we are in the design phase, we have architecture, have structural, MEP, and whenever they have a change, they are all linked. In our project, we have them all linked. And whenever, let's say, oh, the architect moved a wall there, and then there you go, you have the link in your model, and let's say you're the structural, and okay, I'm gonna adjust my beam, my column here, and then, okay, now realign again. And then once I moved my column and beam, then the MEP thing, oh, I need to move my pipes, okay, they move, it's aligned again. Brilliant, so I think everybody understands that. But when we are in construction, that beam was not built exactly where you designed. I know many people say, no, that's not like it. Sometimes people don't believe me and they don't think, oh, we have professionals, they're going to build exactly where we designed. That's not true. The deviation might be minor and then you can ignore, or you can have a big deviation. And you need to bring this information back to the coordination because there is a new model. There is a new model in the process. It's the as-built model. Okay. So what's the implication? I'm going to show image. So yeah, are you sure you have everything? Are you sure everything was built as per design? And I can tell you my experience, the answer is no. So that's our image from Merso. So you have your precast wall. There are some openings there, and I don't know. It might be construction error. It might be that wall, when that wall was built, and the design, let's say, was version 3. I already experienced that in project. So there was version 3, and then 2-3 months later, the design team, no, we need more openings, and we need to move that opening down. But the wall was already built, and the design team did not know that the wall was already being casted. It's a precasted wall, so it's in the file. And then, yeah, there you go. They changed the model. Happy days, keep going. And then when you get on site, that's not the truth because they did not include the as-built model in the equation. So we need to coordinate the as-built model. Another example of that, for example, this is an image using Verity. It's a 3D Edge software. So use Point Cloud, and you can use Immersive, you can use Verity, or you can use other software. All the columns in yellow, they were built outside the deviation tolerance. So what that means, they were built off position. They're not where they're supposed to be. Okay, and it's yellow because it's more than was the tolerance. Let's say if the tolerance was 25 millimeters, they're built more. They're off by 30, 35, 50. I don't know. It's more. So the design teams need to know. Whoever is coming later, oh, if you're gonna install equipment there, you need to know now that now you have less room. And the sooner you know, the better. That's what I'm saying. We need to bring the as-built model to the equation. So in our data center, we are doing that, and we are coordinating, and we are as-builting. You're updating the as-built model, and so all the teams, they are keep in the loop. And so if you're doing offsite construction, if you have offsite fabrication, then you can adjust. We are all good. Okay, just another example. if someone would not think that's relevant. So let's say ducts, pipes. What you see is, what you see here is, in yellow is the design, and where the arrow is pointing is the point cloud. So it was built lower than it's supposed to be. At the right-hand side, you see a section there. So it's built lower. So if your site was already constrained in space, now you have less space. Okay, so and then everybody needs to know, and they can adjust. And if it's really as like it's a red flag, then the construction team has to go back there and adjust that. But if it's not, like you can live with that, let's say, you can adjust the design where it's cheaper and then bring to the site and keep going. So and you save time because you already prepared, it's not a surprise. Okay. So, but how we want to do that in our data center project? So we're gonna use real-time verification. So we use AR, we use GIS, that's a GPS tool that they can connect, and we see what's on site. So there are many equipments. This one is just an example. It's the MetaQuest, so use for that. Use laser scanning as like, because laser scanning, you're gonna get a very accurate report where you could not get maybe just someone with a tablet. So that's when we go closer to get a better result. And we need software to analyze this data because point clouds, they're massive, huge. So you don't want to just link in your point cloud in Revit, create sections and start to look at, is that off position or not? Okay, you can do that if it's a very small project, but the best way is using software to give you a report, the clear report, flagged like column yellow, red, green, and you have your results. In my master's degree, my thesis, I use Dynamo to do this analysis on point cloud. Okay, and now once we pass all those design, stage 2, stage 3, construction, we are always updating, coordinating our as-built model. We completed our facility, and imagine that like you receive an as-built model that you can trust. It's not just someone got the design model and renamed as built and said, oh, that's as built, I built exactly as was designed. No, it's something you can trust and is accurate. So then you can use that to build your digital twin, connect all IoTs and have your enable efficiency and maintenance. That's what's the most costly and more, and that's why we are building. It's to have like operation on this site. So we need to trust that what we have digital reflects the site conditions. Okay, it's faster than I expected. And can open for Q&A session.
Thanks for that, Rubens.